Okay, y'all are going to be doing the Sir Isaac Newton and LeBron James. So the passage is right here. You can hit play. You can go to the question set, and we're just going to do this cold. So the third law of motion, I'm going to go to passage. I'm going to hit Control F. I'm going to type in third law of motion. And then it says it reads, for every action, there is an equal and opposite reaction. Going to go to the question set. And I'm going to look for those answers. Okay, so I can see equal and opposite reaction. Number 2, what does the author describe in the passage? This is wide open, so I want to look at my answers a little bit. The dunking of basketball illustrates 3 basic laws of motion. It's not just about LeBron James. I can mark that one out to begin with because it has to have something to do with Sir Isaac Newton. And this one is all about Sir Isaac Newton and not about LeBron James. So I can mark this one out. So this one's all about Isaac Newton also. Actually, I can mark them all out. I don't even have to look. Because the other 3 are only about one person. That's the only one that has both of them in it. Number 3, it says, read the following sentence from the passage. When LeBron James jumps, he pushes down on the surface of the court. This is the action that Newton mentions in his third law. LeBron jumping is an example of which part? The action and the equal and opposite reaction. The equal and opposite reaction. The action which causes an opposite and equal reaction. Neither the action nor the equal reaction. Let's go look in the passage for jump. Jump. Okay, I'm looking for action, reaction. Okay, when LeBron James jumps, he's driving force into the court. How high he jumps depends on how much he enters. This is the action. So there it is. It says, when LeBron James jumps, he pushes down. This is the action. Okay? So if it had the word reaction in it, I don't need the word reaction. So both the action and, nope, not that. The action, the equal and opposite reaction is not the opposite reaction. The action, neither the action. So we just said this, which one it was. Is it the action or is it not the action? So this is a no. So your answer, you should know by now. Number 4, the force created when the court pushes LeBron James upward is equal to which force? The court pushes. I'm going to go to the passage. And I'm going to, the court pushes. No, that didn't work. Let's go back and look at it again. The force created when the court pushes LeBron James upward is equal to which force? Equal to? His elbow is often equal. Nope, that won't work. Okay, so him going upwards is not about the force of the ball. And him going upwards is not about throwing the ball. So it's either B or D. So him going upwards, is that because of the jump? Or is that because of his landing? So which one happens first is the question. So equal to which force is created when the court pushes LeBron James upward is equal to which force? It's either B or D. There we go. If you were paying attention, you got it. Number 5. What is the main idea of the passage? So your main idea, you go look at the first paragraph and the last paragraph. English physicist, mathematician, Sir Isaac Newton, first law, second law, last paragraph. Basketball players like LeBron James, Michael Jordan, bending the rules of physics and gravity. They are able to perform crowd-pleasing, crowd-rousing dunks. Okay. So, 2 of the best players in the history of basketball. It's not about the basketball. It's not about the basketball. It's not about just the laws of motion. It's about the laws of motion and basketball. There we go. I think that should be all the ones y'all have to do.